All right, welcome back. Now we're going to talk about active physics home activity 1.5, 1.5 here, activity 5. And this is really going to talk about content related mass and specific heat. How do those affect heat transfer? Which really, if we take a look at our standards here, we're going to be talking about the last heat and heat transfer standard 3.4. And this right here is where we're really going to hit the standard in this activity. So let's take a look at what they're going to be doing here. So they just finished up constructing, and testing, collecting data on their universal dwelling, at least the first little mini activity there. Now they're going to, as they go through the next several activities, they're going to start adding to that, getting a little more elaborate with their design. In this case, in 1.5, they're going to investigate the role of insulation. Okay, if we take a look at our pacing guide, a couple things to note here. All right, so misconception alert. It says right here, before I get to that, have some students get a head start and install insulation in their homes while you run this activity. So basically, as they're doing the lab, as they're collecting data, you could have them also start to insulate their homes. I don't really do that. I find that just running the lab itself requires the full attention of the students, and insulating their homes could be for the next day, which 1.6, we'll talk about that in the video when we get to it, probably in the next video. But right here, something to think about. They want you to make sure that you're really linking this to the amount of mass, the amount of matter there, and the different insulation. They're going to notice when we talk about the activity having more newspaper in one container versus less, and it's thicker, but we want to focus their attention on mass because our standard talks about the relationship of mass, and we're going to talk about the different types of substances. We're going to relate that to specific heat. So let's talk about how we're going to do that here as we take a look at the activity. Right here, the what do you think question. Role of insulation more important in summer or the cool of winter? Good discussion point to get students' views on the purpose of insulation. And I also like to show them, just a piece of insulation. Some students may not be familiar with what you're talking about. What is insulation? What is used? So I actually have a little piece I bring in. Of course, you could also just show a picture of insulation if you don't happen to have a piece of insulation laying around. Just be careful if you do bring in a piece because, it is an irritant with the skin. It can cause them to become itchy if they're handling it too much. So just be aware of that. But I like to show them to get that conversation started. And then really, you're just going to have a bunch of different cans set up here and different materials. They have an ice water bath and then also a hot water bath that they're going to be using and taking temperature, recording data for a heating and cooling period. So they have the different containers, different sizes, so different masses. How will that affect heat transfer? And then some students may have newspaper, some may have cardboard, some may have the insulated material. And so you'll be able to see the effects of different material on heat transfer. Now, if you don't happen to have those handy dandy cans that came with the kit, you can easily supplement with, tomatoes tend to come in different size cans, small, medium, large. So you might have to cook a pasta dinner the night before, but you can bring in some empty cans to use. Bring in some newspaper, some cardboard, some insulating material if you have it, or even use some sand. So just different material for them to compare. And then for your ice or hot water bath, you could just use a little plastic container there. And there's two really ways to run this activity. You could have each group have one type of material, different masses, a small, medium, large. And this will just run one class period if you do it this way. And the con is, though, they're going to only have results from one type of material. They're going to have to compare with other groups. So hopefully the other groups are doing as good a job as they are. So let's say one group's testing newspaper, another group's testing cardboard or whatever. So they're going to have to share the results with the class either on a chart paper, Excel sheet, the whiteboard, or even a Google Doc, so that they can actually see the difference in results of different material. And that way you could you could lead into a discussion on specific heat. Or you could do each group 2 or 3 different materials to test, and they get to do each material on their own. The only problem with this is that it will take a little longer in one class period for them to really test each material and collect data. Remember, they're testing different masses of the material using a small, medium, large can, and you can have them even get the masses of that if they, subtract for the mass of the empty can, and then, figure out the mass of the material in there. They'll know the mass of the material. Use a triple beam balance if you got one, or electronic balance. So they're going to do the activity, and then the next page you're going to get to this read-in. And here's the read-in I talked about before, where it actually talks about the 3 ways heat transfers. So a little late, but like I said, I gave you some activities you can supplement to get to some of this content they need to know. So look at that previous video. And then these physics to go questions 1 through 6 are the ones I like. You see them circled here. These are usually the ones I talk about in class because it really gets them thinking about differences in material and how that affects the transfer of thermal energy, differences in thickness or mass as we want them to think about. So I like to assign those questions and then link it to what the data showed in their experiment, different materials, different heating and cooling curves, and relate this to mass and specific heat. So I supplement with some notes for them talking about what mass is, the amount of matter or stuff, and even discuss how more mass will require more thermal energy to produce a temperature change. And it's all in that formula that they're going to need to know. And we're going to get to that formula at the end of this video. But you could talk about heating a cup of water versus heating a swimming pool. And, which do they think would obviously take more thermal energy to change the temperature. So a bit about mass and its effect, and then specific heat, which is kind of a strange word they might not be familiar with. So you have the scientific definition here, and I give that to students. The amount of joules required to raise 1 gram of substance, 1 degree Celsius, and they're like, what the heck does that mean? So I give them kind of a more informal definition alongside of that, which basically specific heat is the stubbornness of a substance to change temperature. If it has a low specific heat, it's easy. If it has a high specific heat, this variable C means specific heat. You can look that up on the formula sheet, MCAS formula sheet. Get familiar with that. It's difficult. So you can compare the specific heat of water versus sand, and then talk about you go to a beach and you walk in the sand, it burns your feet versus the water. And, just get them thinking about that. And I like to follow up with some supplementary labs, having them heat in masses of sand and water. So a small amount of sand, a small amount of water, equal masses, how do they change temperature? And then bigger masses, so that you can compare how did mass affect the temperature change, and how did the different substances affect how easy it was to change the temperature, again, related to specific heat. And another one, there's a link here to an oil versus water lab. This actually isn't my original lab. I can't find it online anymore, but it's linked to my website here, so you could get it. It's a pretty good lab where they compare heat and oil versus water. Be careful with any lab involved in heating things. Things get really hot. Using glass beakers, and especially when you're heating the water, be careful with, heating the oil, be careful, because if it gets hot enough, it will start to pop. So some safety considerations. And this lab uses specific heat in units of calories, not joules per grams degrees Celsius. Just something to talk about. There's different units they could use. But something you may want to do to follow up to really get home that idea of how does differences in specific heat affect how temperature changes when you're adding thermal energy or heat. And it all links back to this. Standard 3.4 is this formula. So again, students can practice this formula now instead of much later in the year when it's introduced later in the pacing guide and the textbook. Give them some practice with this now. This explains why specific heat, and why does mass, and why does how much you're changing temperature, how is that all related to how much heat you're going to add? So when they do the lab, they can use the data they get from it. If they measure the mass, if they look up the specific heat of sand or oil or water, and they can actually use the information they did in the lab to perform calculations and get that. So a couple supplements I throw in there during this activity. So take a day to collect the data, and then take another day or two to do these supplementary labs, really bringing home the point of the relationship between mass and specific heat, and how that affects the amount of energy, thermal energy you need to change temperature in a substance. So I hope that gives you some good information. Trying to go through a little quick and get it all in there for you. And then the next video, we'll talk about following